maybe you guys want to move forward a bit. So we've got 50 minutes before we break for lunch, so I just wanted to come back together and kind of recap and go over what we have kind of learned in the practical exercises so far. So one of the main things we're going to do is a code review. So I think that what I'm going to do is I'm just going to step through like the solution. I'm just going to kind of code, we're going to together code a solution to exercise 2 done with classes. Some of you got like to varying degrees with the solution. And so we're just going to work together to do that. So that's going to take most of this session. A couple of other things that I just wanted to kind of point out that we'll cover in the code review: what's an iterator and what's a generator, context handlers, and the modules versus roll your own, which we, yeah. So these are just a few things that these are just reminders for me to cover really. So before we do that, there's just a couple of slides. So what are some of the criticisms of OOP, of object-oriented programming? So one of them is a lack of reusability. So this guy, who's a famous programmer, said, sometimes when you're coding, by analogy, you want a banana. And instead with object-oriented programming, you get a gorilla holding a banana. And it's like, okay, I want to use this method. I want to use this particular method or technique, but I can't just take that method. I have to bring in this whole class, this whole huge class into my code, and I have to instantiate the class and make sure that it fits, my data fits all of like the different class attributes and everything, and it's a huge headache. So what you want is like one tiny little bit of code, and what you get is a big headache. So that's one criticism. And then, so this is kind of something I really want to emphasize, that it can be overkill for small scripts. So there's definitely, something I want to make sure that people don't leave with the impression that, this is just, the practical exercises might seem like overkill. Some of you did it without classes and it worked fine. So I'm not saying that OOP is the only way to code. It's not what you should do for every single script that you do. But for larger projects, that's when you should think about using an OOP type framework. Because, it's just that way of handling the complexity. So there's two kind of... So it's not everybody likes the OOP model. Personally, I do really like it. And part of it maybe comes down to like an analogy of, do you think like a chef? Do you think like, right, I got to take this recipe, I've got to take these inputs, I've got to transform it in this particular way, which is kind of more like the pandas approach, right? It's like pandas is a slightly more functional paradigm where you go in and you go step 1, step 2, step 3, step 4, output, and I get my output. So you have your input, you have your different functions or processes, and then you get your output. And that's the functional paradigm. And it's kind of like what a chef does, right? They take their input ingredients, they follow the recipe, and they get the output that they want. Whereas the object-oriented programmer, it's more like, oh, you're like a taxonomist. You're like a philosopher almost. Like, well, is the drug susceptible? Is the lineage so an attribute of the drug susceptibility, or is it an attribute of the strain itself? Like, what better reflects reality? It's kind of a little bit more like kind of philosophical, really. And so it totally depends on, different people have different, mental models of how the world works and different strengths and weaknesses. So, there's nothing that says that you have to be an object-oriented programmer to be a programmer, but it's a really common model. So that's why I think everyone should be at least exposed to it. Okay, so we're not going to do that. So anything else we need to... Okay, so in the slides, there's some further reading as well. You have access to the slides. Okay, so the main thing that we're going to do in this session is we're going to try and work through this exercise 2. And so I'm going to do the best kind of live coding, which is unplanned live coding. So you get to see me sit up here and sweat about how to do this all. But basically, we're going to work through this together now. Okay, and we're going to start from nothing, and we're going to write a script that successfully completes exercise 2 in the class way. Okay, so how should we start? Anybody?
Just read the file. Maybe importing the file. Then
Yeah.
So excuse me.
Yeah.
So you're gonna how do you like importing the file? Are you gonna use the class to import the file?
Okay, so this is a key kind of thing. Let's stay high level for now. So this is how I always start every script that's not just like utterly trivial. You stop, you don't write any code, you think about what each stage of the process is, and you write it as bullet points in like plain text. Okay, so you're absolutely right, import the file, that's number 1. But we don't get bogged down in the details. That's like kind of an important thing, because once you get bogged down in the details, you start to like lose your way and forget what you're actually trying to achieve. So we've got to import the data, absolutely. Okay, so we're going to import the data, then what are we going to do? So,
read the file.
yeah, so I think that's kind of what we mean really by import the data. So import the data, read in the, have that data in a kind of Python object. So yeah, that's going to be the output that we have at this stage. So
Transform the columns to more fitting input.
I kind of think that's probably part of importing the data. So I guess we can think about another thing that I often do is like think about what's our target data structure, like what's our target data structure that we want to achieve, and it's to start with it's just going to be a list of lists probably. But yeah, maybe let's not get into that right now. So we're going to import the data, read it into a Python object, like TBC. Okay, so what's like second? We've got this data object. What are we then going to do?
Map out the column.
Sorry?
Map out the column headers.
Yeah, could do. We'll probably get that for free when we import, if we use a library. So we have the import data, then we've got to process the data, right? So what is like going to be the kind of way that we do that, do you think? What kind of Python control statements are we going to use? Or what very common coding pattern? Fully, yeah. So we're going to iterate through the data with a for. We're going to iterate the data with a for loop. Okay, so that's like stage 2. And then stage 3 is when we think, now we're kind of ready to start thinking about what we want as the output of this process, right? And again, I just want to emphasize this is exactly what I do when I'm writing a script for the first time. I think, okay, I almost always read in the data. That's stage 1. Stage 2, yeah, something I iterate over the data to produce like this file, this like data structure that's going to be helpful for me. Help me achieve my goals. So any thoughts about what the data structure might look like? So just a reminder of what we want out of this is these two kind of these two things.
Which delimit.
Yeah, so that's like the printing. That's like stage 4. Yeah. So well, yeah, great. Before we get too far in, create, iterate through the data, create the data structure we want, and it's absolutely fine, and then print out the columns, the tables we want. So can everyone read this? Okay.
Yeah.
Okay, so this is kind of the key. This is the key bit, really, creating the data structure we want. So when, so what do you, is there anything here, that kind of makes you think about any particular data structures?
Yeah, dictionaries.
Yeah, dictionary for sure. Because especially for this one, where we have one sample, we've gone from this kind of layout where we have one row per drug, and we're switching to a kind of wide reading of it. So in a way, this is like a natural key, right? This is like a key going to be a key in our dictionary. That's a very natural way to think about this. So I think dictionary is definitely going to be a big part of it. So our output thing is going to be a dictionary. And again, this is exactly what I do when I'm coding. I make like a little pseudocode version of the data structure that I want to produce. Because if you don't know what you want to produce, if you don't know what the output is going to look like, it's pretty hard to make it, right? That's kind of a really key thing. So know what you're aiming at, and then your life will be much easier. So what do we think? What are going to be the keys in this dictionary? Yeah, sample ID. So sample ID is going to be the key, and then what's the value going to be? Sorry?
Integer.
Integer?
Yeah.
No, because we have to keep lots of complex information here. It's not just not just one value. Could be a list. We could use a list. Could use a list. Could use a dictionary. Yeah, so we could, so if we were going to do it in a list, then we could say, I don't know, aminoglycosides, and then, S or R, whatever, maybe some genes. So we could do it like that. We could do it as a dictionary. And so this would have to be a list of lists because we have multiple drugs per thing, right?
Yeah.
So we'd have to do another, ESBLs, ... fill it, and that would all have to be 7 long. So we could do a dictionary where it's the same kind of thing, but just kind of slightly better structured. Where the drug is the key. And then, suspect is the R or the S. So we could do it, so we could do it like that. Any other thoughts, perhaps related to the name of this, what we've been looking at for the last day and a half?
as like classes.
Yeah, exactly. So the last thing would be we could just make them class instances of a class. So what would be a sensible name for the kind of class that we might want to keep there?
Or samples.
Yeah, sample. So it could be an instance of a sample class. Okay, so now we're like can come out of our dictionary thinking, because now we've got like that first level well organized. You know, we're going to want to look up our samples by sample ID, and now we can like come away from there. We don't have to go into levels and levels and levels. Now we can think about what's our class sample going to look like. So what's the first thing we need? What?
Sample ID.
What's just the boilerplate that we need? Yeah, and that what's the name of the function? Double under, right? Double under in it. Good. Don't forget those double unders. And then what's the first argument to this function? Self. Yeah, right. Okay, so that's what we absolutely need. And then often I just kind of put a little pass there, just so it's valid. Now that's valid Python, and it just lets me like, it scratches like an OCD itch for me that I don't like to have just like invalid Python hanging there. But yeah, so sorry, someone was saying sample ID, right? So we're going to assign that to obviously something called sample ID. Get rid of that. And what kind of variable is this going to be? String. Okay, what else do we want to know about this sample? So here we like flip back and forward with our input data, you know, between our code and our input data. This is like absolutely like the process of how I do this. Like, what's the input data look like? How am I going to represent that in my code? Like, just going back and forth between those is totally like the way to do it. So, okay, we're going to have a dictionary with these as the keys, and then classes that are sample classes, and then we know that they're going to have a sample ID. What else is a kind of what is a sample level thing?
Lineage.
Yeah. So self.lineage, that's going to be a string as well. Okay, what else? Yeah. Yeah, so now we have this like slightly kind of murky, it gets a bit tricky here. It gets a bit tricky here for sure. How do these things relate to each other? So, you know, this is where we have to like, we have to be like this guy and be like, what do we think about how these things relate to each other? So they're all these three columns are kind of related to each other, right?
Yeah.
You have a drug, you have the susceptibility to that drug, and you have the genes that are underlying that susceptibility. So those three are kind of grouped together: the drug, the susceptibility, and the genes. So what do we do with things that form like natural groups in object-oriented programming?
Class them together.
Yeah,
Make them a class.
yeah, we make them a class. Okay, so we'll just like stop there for a minute and like just go over that again. So, and this, it's kind of unfair because I chose like an example that I'm very familiar with: salmonella, drug resistance, lineages. This is like my domain expertise coming in to help me make that decision about how we should group this. And this is like the point, is that to do this for your data, you need to understand the data. You need to understand how to like sensibly organize these classes. And I know that drug goes with susceptibility, goes with the genes that cause the resistance, and they form a natural group. And so the key thing here in your own coding is to find the natural groups within your whatever kind of data things you're producing. And it's absolutely not straightforward. You have to like try a few times and see what works and what doesn't. Until you get to like an answer that like helps everything flow nicely. Like that's totally normal to like fail with one method and have to go back and organize things a different way. Okay.
Yeah, class G.
So yeah, I think drug is like the main thing, because like every drug has a susceptibility and we're interested in that, right? Genes, I mean, we could have a class, but then it would just dangle off drug and it would have a limited number of things in it. So we can think about gene like in a minute.
But are we like assuming for the different samples the same drug would be later susceptible or
Sorry?
so like if you come across two samples
Yeah.
and have the associated drugs, if it's susceptible, it's resistant. There's no way like one drug would be susceptible in one sample and resistant in the other sample.
No, so these are all different samples that have different. So this is where the instances come in, right? So each instance of the like drug, it's going to be like a drug result. It's not. So it's the structure that's common between the instances, and then each instance can have different data in it, right? Each instance can be filled with different things, but they share a structure. Every drug has a drug name, it has a susceptibility, and it has drugs that are associated with it. So for like strain A, drug A can be susceptible. Strain B, drug A can be resistant. But it's that same. It's the structure of it is the same. You have the drug name, the susceptibility, and the genes. So drug. So what did we decide that we need?
And then drug A drug.
Drug name.
Yeah.
Drug name. That's going to be a string. I think. What else do we need?
Susceptibility.
And what kind of variable will this be? Yeah. Okay. Anything else?
But we have genes as a class, but we have genes as a class on its own, even as a bit of.
Yeah, it could do. We actually don't need to make that decision right now. But what we do need is a genes holder, right? No matter what we do, then those genes are associated with drugs. Like that's like the structure of this data is that this SDRA and SDRB gene here, they're associated with this drug. So they dangle off drug. You have drug and you have gene, and like the gene is associated with that drug. So what's this data structure going to be?
You're talking about the final structure.
Yeah, so there's like what is it on the input, and that we don't really care about. That's like we're defining like the output, define the output thing that we want. We're defining like the target here. Like what do we want to make?
List dictionary.
Yeah, I mean, I think it could be a list or it could be a dictionary. Either one is fine. I think let's just keep it simple with the list for now. because it's going to be a list, because even though it's a string in the input, what we want is to represent each gene as its own record. Because in order to make this second one, it's going to be much simpler if we have each gene as its own record. Does that make sense to people? Okay, so self.genes. Okay, so one thing, we're getting close. So if you think about, okay, we need to represent every column in the input there, then we've got sample name, we've got drug name, we've got susceptibility, genes, and lineage. We've got all of these things. So what's missing? What are we currently missing?
Gene coverage.
So we'll probably stick that in genes.
How we want to output them? How we want them to be outputted?
Yeah,
The link between sample and drug.
exactly. Yeah, link between sample and drug. So how are we going to link sample and drug? How does sample and drug relate to each other?
Somebody.
So the sample ID is already an attribute of the sample.
The gene. The gene.
Gene is an attribute of drug. So it's kind of, so how does sample and drug relate to each other? Drug is an instance of a sample?
Yeah.
No. Drug is an instance of a drug class.
I think in the sense that a sample is treated with a drug, so we could have drug as one of the elements in sample.
Yes. So I agree with the second half of what you said, but not really the first half. So, so drugs are associated with samples, I would say. I mean, it depends what you want out of it. It depends on your perspective, but like a sample, you know, if you get a report from a microbiology lab, you know, you don't get a report of like by drug resistant, you know, you don't get all of the ESBL results for that day with all those positives and negatives, right? You don't say sample A positive at ESBL, sample B resistant, sample C susceptible. You get, for one sample, you get, this is the resistance profile, right? Anyway.
Well, that looks like, but okay, again.
Yeah, so it's like, so I mean, and that's just like, you know, the other way, there's nothing hard and fast, there's nothing like fundamental that means that like, but that's the norm, and so that's how I think about it. So, you know, it is a bit subjective, but yeah, I think the strong norm is that the drug results are associated with a sample rather than vice versa. But what you said, was correct, in that we're going to make drugs an attribute of sample. So what kind of data structure is this going to be?
So let me just ask a question.
Yeah, please, yeah.
Before you proceed.
Yeah.
So my view to this is that what you have are genes that have been sequenced from the specific samples.
Mm-hmm.
And so you know a specific sample will have a specific gene.
Mm-hmm.
And that gene confers a specific susceptibility or resistance to a specific drug.
Mm-hmm.
And so you have some a drug being one of the attributes of sample could have overlooked the genes that could be present in that sample.
Sorry, say again?
If you have drugs as one of the attributes of samples, the class sample, are you overlooking the genes that that are present in that sample?
No, because drugs. So it's it's like hierarchical. So the top layer of the hierarchy is sample, and then there's two ways now we can arrange the hierarchy. We could go sample, and then genes, and then drugs, but not every sample has those genes, right? So it's kind of, well, like how, when a strain has no genes, like, for most of these, like, how then do we link? It just doesn't really make sense, right? To like go sample genes drug, because they all have results for drug, and it's positive or negative, and then if it's positive, then they have a genes. So it's like gene. So for me, that kind of naturally leads it to be the hierarchy is sample, then drug, because you always have a drug result, whether it's positive or negative, and then genes dangles off drug because it's only there for some of them. Yeah. But we always capture it whenever it's there, and it just dangles off the drug result for one drug result for a sample.
So how does lineage associate with all this? Is it?
How do you think?
It's the lineage of the resistance, or I don't know.
So sorry. The lineage is a sample attribute. It's just repeated in the output of this tool. It's a sample attribute. It's like, what lineage is that bacterial sample? And that's what I mean about like having that like domain-specific knowledge, about how these things relate to each other. That's it's kind of an unfair thing that you didn't know that, if that makes sense, because like it's then hard to figure out like how to arrange these things, because you can't. I couldn't do a good job of this for something that I knew nothing about, because I don't know how these variables relate to each other. So it's like, you're kind of codifying your understanding of the problem of this phenomenon into like the code. So you have to understand it before you can code up a good solution. So that's part of it.
So the lineage is like the grouping. I can see that.
Yeah. So it's like, with SARS-CoV-2, we have like Omicron, Delta, Alpha, Beta, right? We have the different lineages. And so this would be like, the different samples for SARS-CoV-2, you would have like, maybe the point mutations, like, P501S or whatever it is, and then like yes, no, and then it also has the lineage associated with the sample.
So just to add on that, if you look at it from a biological perspective, like you would have a bunch of samples that gets collected from different regions, right? And then those samples get brought to an institution. So they have maybe 10 drugs on them, and they want to test those 10 drugs to see how effective they are against all the samples they collected, right? So each sample will be tested against those 10 drugs. So that's why the sample ID is important, because now you know person A, person B, whatever, right? And then what the lineage is telling you is, say this person is coming from a big city, whereas the second person is coming from a smaller city. So the second person might have a mutation that's developed from the main city. And this could be two different vectors, different elements. So the lineage is telling you this might be a parent, and this person has the mutation of the parent. So when you start with like the main sample, and then all the drugs that's been tested, positive, negative, blah, 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 and how suspectable it is. And then I think from the lineage, it's more like we want to know where it's originated and how the mutations are done effective over time. So I think with SARS-CoV-2, they said that a lot of mutations occurred when people had already other symptoms like TB, or if they had a weak immune system, that might have caused maybe a mutation of that.
Okay, so what's drugs? What kind of data structure is drugs going to be? Yeah, great. List. Okay, so now we have like everything that we need to kind of arrange the data. So maybe we just make a note to ourselves that drugs is going to be a list of drug instances, right? And you see how I use the capitalized to tell myself that it's the class that I'm referring to. So drugs going to be a list of drug instances. So this is how we relate. So now we're getting close to like the data structure that we want. So now sample here relates to this sample, and sample has a drugs list, and this is going to be full of these drug results. Okay, so we have the kind of data structure that we want out now. So now we're really, and then okay, we need to print out the tables we want. So now really we're ready to start like coding properly. So there's a good coding practice to wrap, rather than just like start coding right now here. We wrap things in like what's the main function. So this is just a default name that people use. And this is like a function that's run. And we use this little thing, this pattern. So when you get later on into importing code into different modules, then when you import code, if you don't use this structure, then the whole file will run. So this is just a thing to like future-proof your code, really. But we can get rid of that because it's probably just confusing. So now, but it's still a good practice to put things within a main function. So main is going to run the function. So the first thing we need to do is import the data. So I'm going to cheat a little bit and copy in from what I made earlier. So we're going to use another function to do that. So this is a called read in file. Takes an in handle as the argument. So that's just a path to a file as a handle. And then we do this thing that's called a context manager. Where we use this kind of special with open in handle as fi, so file in. Then we get the records from that using the CSV module, dict reader function of that, and then we make an output of that. And then so the advantage of this this context manager is that you never have to close the file. The file is automatically closed when you get to here. So this is just another good practice. It's called a context manager. Okay, so now we're going to use this CSV module to read in our CSV. And this dict reader thing. So let's start running this code. So that was one thing I noticed with a few people, that you kind of waited a little bit too long before you started to run the code. So you should be running don't wait until you have like 5 functions strung together before you start running, because it's much harder to debug. Like build up as you go and make sure you test everything before you do it. So as part of the main function, we're going to read the in file, which I'm going to just grab from here. So this is just that file that you guys downloaded. Okay, so I'll make it big in a second. Okay, so we've got error. People seeing that?
Important.
Yep. So I forgot to do the import of this module. This isn't loaded normally, so we have to import that normally. So we have to import that. Okay, so now we're getting no error, but we're not really any the wiser. What we really need to do is print it to have a look at it and see what it looks like. That's another really important thing. So we're going to use another module called pprint, which stands for pretty print. And it just prints things in a nice way. So this is how we use preprint. So now, okay, so what happens when this code runs is the main function runs, which sets this variable, then calls this function in handle. So we're going here now. So then it's doing all these things, including this pretty print. So let's have a look at what that looks like. So this is what when we did a dict reader. So CSV dict reader does this really nice thing where each line, it makes a dictionary where the key is the column header and the value is just that row in the, whatever that row in the thing is. So when we use dict reader, we get each line is the dictionary with the key as the column header and the value as the whatever's in that particular row. So we have lots and lots of dictionaries, all of which have the same keys as the header. So dict readers are nice. Okay, so we've had a look and things look sensible. We've got this thing, so we're in a good place to start. So we kind of ticked off number one. We've ticked off import the data into a Python object. So the only thing, so this is we're doing because it returns an iterator, a generator rather than an iterator, but we're not going to go into that right now, but you can read more about that. That's why we have to specify that we want it as a list. So don't worry about that. Okay, so what do we need on this line to kind of move forward properly? So people familiar with like returning things from functions?
Assign. You assign the output to a variable.
Yes. So when we get something out of a function, we need two parts. We need the return, which chunks it out of the function, and we need to assign it to a variable which catches it as it gets chucked out. So we're just going to call this records. So now we catch that output into records and we can do more stuff with records. Okay, so now we need a kind of function which we'll call make classes or something, which is kind of unspecific, but we'll have to do for now. So we're going to run this, and we're going to run it on this records thing. So let's just remind ourselves what records looks like at this stage, because we're about to start writing code on it, and it's just this exact same thing, right? So it's a list, which we can see here because there's a square bracket at the bottom. Square bracket, so it's a list of dictionaries. Okay, so we're going to iterate over this list. So we'll give it a very imaginative name of each record in records. So how are we going to, so the problem here is how are we going to stop? So that each line if we make a new sample for each line, we're not capturing this well, right? Because each sample has multiple lines. So if we make a new sample on each line, it's not going to go well. So how do we make sure that we don't make a new sample for each line? Dictionary, yeah. And so we use a pattern, a really common pattern called a default dictionary. So this is like basically how you should use dictionaries, or how you use dictionaries very commonly. So firstly we need like our output dictionary. Let's just again remind ourselves, lots of print statements, what each record looks like. Okay, so I'm just gonna, get rid of this pretty print. So this is what each record looks like. So it's a dictionary and the key is key is sample, and that's the sample ID. So each record okay, so this is our sample name, is each record sample. Okay? So then how we use the default dictionary is we say if, okay, I'm gonna make that into a variable to make it a bit more explicit. If sample name in, I'm going to call it as the output dictionary. So if the sample name is in the output dictionary already, okay, we have to do something, but for now we'll just pass. If it's not already there, what do you think we're going to do? Append it to what?
As a key.
Add it as a key, yeah. And what's the value going to be? No, because that's the key.
Oh,
It's for the record.
No, it's gonna. We've made this, so we did it already, right?
Oh, the class.
Yeah, it's an instance of the sample class. So we already thought about this. So then we're going to have. So this is kind of how. How we already decided we were going to do it. Okay, so we'll just finish this little section and then we'll break. How are we going to use this? So at the moment we have these things and it's just kind of a holder, everything's just kind of a holder. So how do we actually populate this with data?
Should we define the arguments there?
Yeah. Yeah. Okay. So we catch them. We're catching them here. So we need to throw them down below. This is going to be sample name, and then let's just like kind of make it a little bit consistent. And we want this is going to be the lineage. So we're going to do the sample name, sample lineage. Okay, so now let's see what we're making here in our output dictionary with another pretty print. Okay, so we have a dictionary where the key is the sample ID and the value is sample object. So this is exactly what we said we were going to do, and it looks good. So that is how we kind of do it the first time. We see a sample, because that's like all, we don't, when we see this sample again, we don't need to make a new sample, right? When we need to see this new sample ID. But when we see it the second time, we need to add a new drug, right? So that, because it's 12:30 now, there's a code example in the shared Google Doc, in the shared Google Drive, that kind of finishes this off, which you're free to look at in your own time, and I'm very happy to answer any questions about it. But so this is kind of just a quick demonstration of how we kind of just try and solve these problems. So really fundamental is think through before you start coding. How much easier is our life, once we get into like the thorny details, when we've already decided like what we want out. It's much easier, rather than having to like do those two things simultaneously. It's the difference between like driving somewhere guided by a sat nav and driving and having to figure out where you're going, like somewhere you don't know, without any other guidance. And like you see something coming at you, like, do I need to take this junction off? Yes, no, yes, no. And it's the same there. Like you're going to come across problems if you haven't thought about it. If you don't know where you're going, it's really easy to get lost. Okay, so again, just like this was the first time I've taught this kind of material, so I've definitely learned a lot about how I will teach it in future. So sorry that you guys were like the guinea pigs, but you did really well. I think everyone engaged with the material, really enthusiastically, and I really appreciate that. If you have any specific feedback, I'm happy to receive it in person, or I'm sure there'll be some kind of post-course survey. Happy to receive more feedback on that as well. There's example code in the Google Drive for the two different ways of doing it. And if anyone's really enthusiastic, then there's also a few other exercises that we didn't get to. So another practical exercise. And then in fact, we didn't have time to study the getting to grips with like the BioPython. So again, people can run through these materials by themselves, and I'm happy to support, like, after, we're going out for dinner this evening, but there's kind of a slot in the evening that we could discuss these things between 5 and 7. So there's that, and then there's some best practices as well, which we've studied some of as we went through that exercise, but there's some more slides there if anybody really wants to get stuck in. So those will be available to you. Those are currently available to you and will stay available to you in one way or another. Okay, thank you all.